So now, let us jump to question number 4. So now, question number 4, it reads as follows. It says to us, given with 3 cosec theta plus 2 is equals to 0, and theta, it is within the interval of 270 degrees and 90 degrees. This is where theta it is located or situated between 90 and 270. So use a sketch to determine the value of the following without using a calculator. So we're going to have to determine the following without using a calculator. So that means you need to show the sketch. So we're going to draw the sketch. But the sketch, it's going to solely based on this information provided to us. The thing is, when it comes to drawing a sketch, it's either you draw in first, second, or third, or fourth quadrant. But which quadrant are we going to choose? It depends on this information provided to us. Let me show you how to utilize this information to draw up your sketch that you're going to use for calculations. So that means we're going to open up a Cartesian plane. We're going to open up a Cartesian plane just like this. So we have y-axis, we have x-axis. So now, which quadrant are we going to choose? It depends on this, okay? But firstly, let us start with this information. We're going to rearrange this equation, and we're going to make our trigonometric ratio to be a subject of the formula. So everything that we see on this side of the equation, we're going to take it to the other side of the equation. So let us try to solve this equation first. So let us start by taking 2 to the other side. So that means we're going to have 3 cosec theta is equals to 2. It's going to be negative 2 when it gets to the side of the equation. And then we divide both sides by root 3. We're going to have cosec theta. We're going to have cosec theta is equals to negative 2 over root 3. Actually, mathematical, this is not correct. We're supposed to conjugate this, multiply by its conjugate, because mathematical, even calculator will give you the conjugated final answer. We don't want a root under the, we don't want the root number in the denominator, but it's fine. We can just let it here. It is still fine. So now this is what is happening. We are familiar with trigonometric ratios. We are familiar, most definitely we're familiar with this. So, because we know that at some point, what is x over? We know we have x over r, y over r, x over y. We know all of those things. But now, because we have cosec, what does cosec actually related to? If you forget, this is my hint. I agree we know we have what you call SOHCAHTOA. This is how I call it, the other one. I don't know if it is on the books or what. I call it CHO, SHA, KA. So this is cosec, which is when it's opposite of hypotenuse, this is going to be hypotenuse over. This is the inverse of our trig ratios that we are used to. So here is chosha cow. Chosha cow is soka toa. So chosha cow. So it's the same as that. So here it's cosec, cosecant, which is hypotenuse over opposite. And then secant, which is hypotenuse over adjacent. And this is cotangent, which is cot adjacent over opposite, which is opposite of that one. So we can see that cosec, it goes with sine, and then sec, it goes with cos, cot, it goes with tan. So here we're talking about the cosec. That means, what is the cosec? Cosecant is the inverse of sine. So what is the inverse of sine? It's going to be 1 over sine theta, which is the same as negative root 3 over 2. We're also going to take the inverse on this side of the equation, right? That's how we can do this. But remember, we don't want 1 over sine theta. We want sine theta. Again, I'm going to reverse it. I'm going to take the inverse once more again, and then I'm going to reverse it to be something that looks like this. So that means sine theta, it is the same as negative 2 over root 3. If it confuses you, we can just cross multiply again and solve for sine theta. You're still going to get the same thing. Okay? Remember, cosec is this, which is 1 over sine, is the inverse of sine. So remember, I think I made a mistake there. So this supposed to be this. Sorry, 1 over sine, which is this, is gonna be the inverse of that. It's gonna be inverse of that. Let's see, 1 over sine theta. It is this, which is negative 2 over root 3. And therefore the inverse of this, we interchange the denominator and numerator. So that means here it's gonna be, let's see, that means here it's gonna be root 3 over negative, it's gonna be negative root 3 over 2. Okay, so that's how we do this. And therefore, now let us talk. Now, this is what is happening. We know sine, we don't know cos. Hence why we wanted to convert cos to sine. Now, this is what is happening. We know that sine, it is given by what? It is given by y over r, right? Sine is given by y over r. So, between y and r, which number can be negative? It is y. R will always be positive, which is our hypotenuse. So y can be negative because you know that we can have negative y values. We can also we can have positive y values. We can also have negative y values. So sine theta, it is situated in which quadrant so far? Where sine theta is negative, is negative where y is negative. Y can be negative in this quadrant. Y can also be negative in that quadrant. But this information is the final information that's going to tell us which quadrant to pick. So they say to us theta supposed to be between 90 degrees and the 270 degrees. So that means they say our theta is supposed to be between these two quadrants. So that means the quadrant that we're going to utilize, it is this quadrant. That means this fails because theta doesn't fall within this interval. So this is where we're going to draw our diagram. So let me open, okay, so that's where we're going to draw our diagram. So let me do this. I'll just erase here, 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 and there. And therefore, we draw our diagram in this quadrant. Remember, your vertical line will go to your y-axis. I'm sorry about my drawing, guys, as long as you get the idea. So that means this is how our diagram will look like. Oh, I apologize about this. So this is where our diagram will be situated. So this will be angle theta, right? So remember our y, it's negative root 3. And our hypotenuse will be positive 2. Now, how to determine x? We're going to say x squared will be equals to r squared minus y squared. Okay? Will be r squared minus y squared. So what will be our r? Our r will be negative, will be positive 2 to the power of 2 minus y in this case will be negative root 6 to the power of 2. So here we're gonna have 4, and then there we're gonna have positive 3. This negative is from this formula. And therefore our x squared will be equals to 1. Remember, we are not looking for x squared, but we are looking for x. We're gonna take root side on both sides. And immediately when you take root side on both sides, you take plus or minus. So that means our x will be equals to plus or minus 1. But because we are talking about third quadrant, so our x will most definitely be negative. Okay, so our x will be negative 1. Why? Because we are on third quadrant. So that means our x here will be negative 1. Now we can do calculations without using a calculator. They wanted us to calculate cos theta. So remember this, you write all of these things on your book, right? It's 4 marks to start with. You draw your diagram, you determine your x, you show them how you determine your x, and then you are good. So this one you can also draw it there, or you can draw it somewhere with a pencil on your question paper, just not to confuse yourself. But you can also draw it there on your question paper. It's fine. You are doing your calculations. So cos theta will be equals to how much? Remember, cos theta, it is x over r, or you can just say it is adjacent over hypotenuse of this diagram. So our adjacent will be -1, and hypotenuse will most definitely be +2. And therefore, this will be your final answer. Now, we move to the question number 2. Question number 2, they want us to determine sine theta, tan theta, cos theta. So sine theta, we have already determined it over here. We don't even have to complicate our lives. So sine theta is -√3/2. So sine theta will be -√3/2 multiplied by tan theta. So what will be our tan theta? Let's go to our diagram. Tan theta, it is opposite over adjacent. So theta is here, opposite is -√3, adjacent is -1. So okay, let me write it, it's fine. We have -√3 over -1. Divide by cos theta. Divide by cos theta. Cos theta is this one. We have determined it, which is -1/2. So we can just write it over there, -1/2. And therefore, what's going to happen is, let me write it here, okay? Let me write it here as I continue. -√3 multiplied by -√3 is going to be positive. It's going to be +3. And therefore, 2 multiplied by -1, it's going to be -2. So you see this divide over here, because you want to show them that we are not using the calculator, I'm going to write it over here. So this is the same as -3/2 divide by -1/2. And the following step will be -3/2. Now this divide, I turn it into multiplication, and I take the reciprocal, which is going to be 2/1. And therefore, this will cancel that. Negative by negative will be positive, and then my answer will be +3. You see, the thing is, they say to us without using calculator. So these steps, they emphasize that we didn't use calculator. Because if you substitute over here, and then you go to straight your final answer, we would assume that you use your calculator. You see, so just draw these steps to show that actually you didn't use your calculator. Okay, and therefore that will be question number 4.1.1. Now we move to 4.1.2. 4.1.2, it says to us, if theta is equals to 25 degrees, and then alpha is equals to 38 degrees, determine the value of cos 2 alpha minus theta correct to 1 decimal place. So we want to determine the numerical value of this expression. So our expression, it is given to be cos 2 alpha subtract theta, close bracket, is equals to cos 2. Therefore, we are given the angle alpha, which is 38 degrees. Subtract, we are given angle theta, which is 25 degrees, close bracket. And therefore, here we have, it's fine, we can just say cos 2 multiplied by 38 is going to be 70, it's going to be 76, right? 2 multiplied by 38, it's 76 degrees, subtract 25 degrees. And therefore, we have cos 76 minus 25 is going to give us how much? 51 degrees. And therefore, what is cos 51 degrees? You're going to say cos, make sure that your calculator is in degrees. Cos 51 degrees to 1 decimal place is going to be 0.6. It's going to be 0.6. And therefore, this will be our final answer for 4.1.2. And then we move to 4.2. We move to 4.2, which is 6 marks. Now 4.2, it is the simplify. Simplify the following expression without using a calculator. So here we have a cos sec squared 60 degrees plus 10 squared 45 degrees plus sec 60 degrees. They want us to simplify this expression, right? Without the use of calculator. So when they say without the use of calculator, you're supposed to be familiar with your special angles and the diagrams for special angles. But the thing is, you can use your calculator, because I know people forget that there is a lot going on, guys. Even in grade 12, you need to know these things till grade 12. But if you forget these things, I'm going to show you something. You don't have to calculate everything, because when you can just punch everything to calculation and write final answer. It's wrong. You're not going to get that 6 marks. It's wrong. So for you to use a calculator, I'll give you the hint, a trick how to do it. So what is cos x squared? We know that cos x squared, Chosha cow, cos correspond with sine. So this is the inverse of sine. So we know that this will be 1 over sine squared 60 degrees, plus tan squared 45 degrees, plus sec, Chosha cow, right? Chosha cow. That means sec, it goes with cos, right? Sec, it goes with cosine. So this will be the inverse of cosine. So that means here we're going to have 1 over cos 60 degrees. Now the second step is I'm going to take these two out of the bracket. So that means I'm going to have 1 over bracket sine 60 degrees to the power of 2 plus open bracket tan 45 degrees to the power of 2 is equals to 1 over cos 60 degrees. Now, this is what is happening, cos 60 degrees. This is what is happening. They know that you know sine 60 degrees is how much. You don't have to use your diagram, but you can use it if you feel comfortable with it. So you can literally say sine 60 degrees on calculator. Don't punch everything. Please, don't take this thing all of it and punch it on a calculator. You can just punch your sine 60 only. So simply, if you know it by head, it's 1 over 2. It's 1 over 2. You can just do it or whatever. So, or you can just go to your calculator and say sine 60 degrees. Apparently, it's root of 1. It's root 3 over 2 to the power of 2 plus tan 45. I think it's 1, right? If I remember, tan 45 is 1. They think you know that it is 1. You see, and but you can just punch it on only this and write it there. And therefore here you're going to have 1 over cos 60. You can just say cos 60 on your calculator, which is 1 over 2. They would think that you know what is cos 60. You see, this is the hint I can give to you. And therefore now here we're going to have 1 over this to the power of 2 is going to be 3 over 4. And therefore 1 to the power of 2, it is 1. And therefore here we're going to have 1 over 1 over 2. Let me teach you something again. So here we have fraction over fraction. So this is 1 over 3 over 2. I'm going to take this 3 over 2 at the top. But when I take it at the top, I'm going to take the reciprocal. Or you can just do how I showed you, 1 over 1, divide, write it there, or whatever. So that means here it's going to be 4 over 3 when this 3 over 2 goes at the top, plus 1. And therefore this 1 over 2, when it goes at the top, it's going to be 2, or it's going to be 2 over 1. And therefore here we have 4 over 3. 1 plus 2 is 3. And therefore LCD is going to be 3. Here we're going to have 4. 3 multiplied by 3, it is 9. And therefore here we're going to have 3. And therefore what will be 4 plus 9? 4 plus 9 will be 13 over 3. And this will be our final answer. This will be our final answer for 4.2. 2. If my math is correct, my algebra is correct. We can also confirm. So now 4.3. It says to us solve for theta correct 2 decimal places. If this equation it is with whereby theta is within this interval. So we are given the equation for 3 marks. We are given the equation. They just want us to solve for theta. So, and again, our solution is supposed to be between 0 and 90 degrees. So what we're going to do is we're going to say 2, 10, theta minus 45 degrees is equals to 0. So we want to solve theta, right? We can't just transpose 45 degrees. We're going to have to get rid of 2 first. But how are we going to get rid of 2? We're going to divide both sides by 2. So here we're going to have 10 theta minus 45 degrees is equals to 1 over 2. And therefore, we're going to take second function of tan on both sides of the equation. And on this side, we're going to have tan arc, or second function of tan, 1 over 2. And therefore, theta minus 45 degrees will be equals to, what is the function of tan arc? It's 45, right? If I'm sure, second function 0, 0.5. I'm lying. It's 26 to 2 decimal places, 57 degrees. And if I'm going to transpose 45 to the other side of the equation, I'm just going to say plus 45, and then my answer will be 71,57 degrees. Therefore, you can see our theta is between 0 and 90 degrees. So this is the correct solution. Only for 3 marks, you are done. You will see when you get in grade 12, this is called, even in grade 11, it's called general solution. You're going to have to treat it a little bit differently when you're given the interval. You're going to use the integers, but for you, just end here, it's only 3 marks. So this is how we solve for theta. Okay? This is how we solve for theta. So now let us do question number 3. Now, question number 3 is analytical geometry. So think of all the basics that you know, understand under analytical geometry. So now, starting with question number 3, the statement says to us in the diagram below, A is 4:4, B is 2:-1, C is X is to Y, and D is -6, 0 are 4 vertices of quadrilateral ABCD. To start with, we are not told that what is the name of the quadrilateral. They just say it's quadrilateral. It's not parallelogram. Why? Because you are not told, unless if you have to prove it is a parallelogram. Now 3.1.1, it says to us, calculate the gradient of AD. So to calculate 3.1.1, they want us to calculate the gradient of AD. Where is A? Here is A, AD, gradient of AD. So to determine the gradient of AD, you can just say gradient of AD will be equals to y of A subtract y of D divided by x of A subtract x of D. Remember, here's the thing. You can use y2, y1, x2, x1. The thing is, why am I doing like this? I love it. I love doing it like this because I don't want to confuse ourselves. Because sometimes we forget which one is 0.2, which one is 0.1. Now you do wrong substitutions. But if it's like this, you can see y of A, you go for A. A is here. You don't have to confuse yourself, right? So y of A, it is +4. It's +4. And then y of D, it's 0 over x of A, it's +4, and x of D is -6. That means it's going to be +6. So here we're going to have 4 over 10. So 2 goes many times into 4, it goes 2 times. And then 2 goes many times into 10, it goes 5 times. Then our answer will be 2 over 5. That will be the gradient of AD. 3.1.2 says to us, determine the equation of line BC, which is parallel to AD. So BC, the equation of this line. We can't determine the equation of this line because we don't have the coordinates of C. So how are we going to determine the equation of BC? We are told that BC is parallel to AD. So we know that the parallel lines, they share gradient, meaning they have the same gradient. They have the same steepness because they are parallel. So they have same steepness. So that means, or slope. So that means gradient of the very same line that we want, which is BC, is the same as gradient of AD. Why do we say that? We give the reason. It's because DA, it is parallel to CB, because those lines are parallel. So now we can say y minus y b sub is equals to gradient of BC x minus xb. We'll say this equation, it will pass through point B. Hence why I said y of b and x of b. You can say y1, x1, it is still fine. So the coordinates of b in this case will be 2:1. And therefore y minus y of a, or you can use that thing of determining c first, it is still fine, but this is quicker and faster. So y of b in this case is -1, but I'll say it's +1, which is equals to gradient of bc in this case is going to be 2/5 x, and then what is x of b? X of b is going to be +2. Then we have y plus 1, which is equals to this multiplied by that, it's going to be 2/5 x, and then this multiplied by that is going to be -4/5. Now let us transpose 1 to the other side of the equation. Here we're going to have 2/5x, and then here's going to be -1. So -1 and -4/5, it's going to give us how much? It's going to give us -9/5, if my math is correct. You can prove it, we can confirm it with your calculator. When we transpose 1 over here, it's going to be -5/4/5 minus 1. Yeah, I think we're going to get -9/5. That will be our y-intercept. Therefore, that will be 3.1.2. And then 3.1.3, it says to us, determine the coordinates of E, the midpoint of line DB. The midpoint of line DB. So we want to determine the coordinates of E, which is the midpoint of this line DB. So we have the coordinates. So how to determine the midpoint of that line? So to answer question number 3.1.3, we know that to determine the midpoint of the equation. So you want the midpoint of what, Kunje? The midpoint of line DB. Midpoint of DB. Let's write the coordinate, the midpoint of E. What are the coordinates of E? It's going to be x of E is to y of E, which is equals to x of D plus y of B divided by 2. So it's xx. I made a mistake there. We're going to say x of B plus x of D plus x of B, y of D plus y of B divided by 2. Now we equate x to x's, y to y's. So that means x of E will be equals to x of D plus x of B divided by 2. And then y of E will be equals to y of D plus y of B divided by 2. Let us start by solving x of E first. X of D is equals to how much? Let's go. X of D is -6. And then y of B is equals to how much? Y of B is equals to +2 divided by 2. Y of E will be equals to, now y of D is equals to how much? Y of D is 0, y of D is 0. Y of B is -1. divide by 2. Now let us calculate. Negative 6 plus 2 is negative 4. Divide by 2, it's negative 2. This will be x of e. And therefore, y of e is going to be negative 1 over 2. Therefore, coordinates of e will be negative 2 is to negative 1 over 2. This will be question number 3.1.3. Does this make sense? Yes, they're both negative, x and y. Makes sense. This will be 3.1.3. So let me just write it here because I think I'm going to erase. Here we have negative 2 is to negative 1 over 2. So now we move to question number 3.1.4. 3.1.4, it says to us, given that the quadrilateral ABCD is a parallelogram. Now we are told it's a parallelogram. You see, calculate the coordinates of point C. So this is what is happening. You see, this is a hint. For the fact that they tell you it's parallelogram, we know that one of the properties of parallelogram, the diagonals, they intersect each other at point E. So these diagonals, they share the same midpoint. So the coordinates of E that we got, we're going to use them along with coordinates of A to determine coordinates of C. We're still going to use the midpoint formula there. So to answer 3.1.4, we want to determine the midpoint of this line. Line what? AC, line AC, line AC, whereby we're going to use coordinates of E as the midpoint. So x of E, y of E will be equals to our midpoint, which is x of A plus x of C divided by 2, y of A plus y of C divided by 2. So x of E, x to the x's, we equate x to the x's, right? And we equate to y's to the y's. Now let us substitute. X of E, we said is how much? We said it's negative 2, right? It's negative 2. And then x of A is how much? There it is, it's positive 4. It is positive 4. X of C is what we are looking for. Divide by 2. Y of E is negative 1 over 2. Yes. Y of E is negative 1 over 2. And then Y of A is positive 4. Y of A is positive 4. Y of C is what we are looking for. Divide by 2. Let us start with this equation. So we're going to cross multiply. Here we're going to have 4 plus x of C. And then here we're going to negative 4. This multiply by that. And then we transpose 4 to the other side of the equation. X of C is going to be equals to negative 8. Does that make sense? Yeah, there is it. And therefore, same applies to here. We cross multiply. We're going to say 2 multiplied by the whole thing. It's going to be 2, 4 plus y of C, which is equals to 2 multiplied by negative 1. It's going to be negative 2. We divide both sides by 2. Here we're going to have 4 plus y of C, which is equals to negative 1. We divide by 2. And then we transpose 4 to the other side of the equation. Answer will be negative 5. So the coordinates of C will be negative 8 is to negative 5. That will be 0.122. Okay, I hope that was clear. Negative 8 is to negative, here we have negative 8 is to negative 5. C. Without wasting time, moving fast again, we move to 3.2. 3.2 says to us, given that P, Q, R, and S determine the value of X if PQ is perpendicular to RS. So the thing is, for the fact that these are perpendicular, meaning the product of the gradient of PQ and RS, they're supposed to give us negative 1 if they're perpendicular. So that means if I take the gradient of PQ, I multiply it with the gradient of RS, I'm supposed to get negative 1. So for this fact, it is known that PQ It is perpendicular to RS. Line that are perpendicular, the gradient, when you multiply them, the product of their gradients will be -1 all the times. So let us determine the gradient of PQ. So we're going to say y of P minus y of Q divided by x of P minus x of Q multiply by gradient of RS. We're going to say y of R minus y of S divided by x of R minus x of S is equals to -1. So what is y of P? We go there. P, where is P? There is it. Y is equals to 3. We substitute there. Y of Q, there is it. It's 4. We substitute 4 over here. X of P is -2. We substitute -2 over here. X of Q is +1. We substitute 1 there. And then y of R is -4. We substitute -4 there. Y of S is what we are looking for. Value of X, which is X. We just substitute the X over there. And then X of R. Y of R is 1, not 4. Y of R is +1. Y of R is +1. X of R is -4. And then X of S, it is X. Now I'm tired. Y of S, what is Y of S? Y of S is 4. Swap them. Y of S is 4. Y of S is 4 is equals to -4. Let's confirm. X of P, Y of P, 3, Y of Q, 4, X of P, -2, X of Q, it's -1, and then this is also correct. So now let us do algebra then. 3 minus 4, we're gonna get -1 over 2 minus this and that is going to be -3, and therefore this minus that is -3 over -4 minus x, which is equals to -1. And therefore we multiply both sides by 3. This is going to be positive. Multiply both sides by 3, we're going to have -3 over -4 minus x, which is equals to -3. We multiply both sides now by 1 over 3. We're gonna have -1 over 3. We're gonna have 1 over -4 minus x, which is equals to +1. Now we cross multiply, so we're gonna have -4 minus x is equals to 1. We transpose for this side, and then our x will be -5, if my math is correct.